As I keep reminding you here, software is complex, to the extent that we are almost never going to get it right first time. The requirements will be wrong, we'll misunderstand the problem, our solution won't be as good as we thought it was, our first guess won't land with our users, and we'll need to try again. Some new idea will no doubt come along and will change our understanding and will give us new ideas that make us want to change our code. As far as I can tell, this is normal and inevitable, and a fundamental aspect of the creative process of software production. The result of all of this is that the only sensible response is to take an evolutionary, incremental approach to design. So what does that involve? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content, hit like as well. I'd like to begin by thanking our sponsors, Equal Experts, Octopus and SpecFlow. They've been supporting our channel for a long time now, so please do check out their links in the description below to say thank you. One of the best ways of sustaining our ability to evolve your design safely is with test-driven development. My new training course, Test-Driven Development and Behavior-Driven Development Designed Through Testing, explores this idea in some detail. It teaches how to write effective tests that promote great design and works through the interesting and sometimes challenging parts of test-driven development. Take a look. There's a link in the description and you can click the link there too. I feel like I've been on a bit of a roll lately, talking about architecture as an ongoing process of guided evolution and TDD as a means of steering our designs. There's good reason for this. I think that maintaining the ability to create our systems incrementally is probably one of the most important aspects of good software design. But it certainly takes a certain kind of defensive mindset to work this way. It's an illusion to imagine any complex system springing fully formed from the mind of its creator. It simply doesn't work like that. We might have a great idea that inspires us and that we build upon, but I'd argue that human creativity, pretty much in any form, is a process of iteration, exploration, learning and discovery. That means, particularly for something as complex as software, we need to work in ways that keep our options open. The sooner we close the door to our ability to change our minds, the sooner we've discarded any hope of learning and so creating something genuinely great. This means that working in ways that retain our ability to change our minds is very important, fundamental to the process of good software development. I'd go as far as to say that the reason that design matters in the first place is down to our ability to change it as we learn new things. For me, the defining property of great code is that it's easy and safe to change. That may sound like a pretty hard line to draw in the sand. Surely great code has to be fast, efficient, elegant, beautiful, readable, clear. Yeah, of course. But how do you put those things into great code? I can't imagine and have never seen any good code base that didn't evolve over time. And the great ones were great precisely because they had evolved, even when they started out with some good ideas. So if our aim is to liberate our ability to evolve our solutions, I guess the first step is recognizing the problem. If we assume that our job as software developers is to create perfection from day one, we're fooling ourselves. But it also means that we'll be too tied to our ideas. People with this mindset are often extremely defensive of their ideas. Someone pointing out a mistake is seen as an affront or a personal failure. Sorry, but this is just dumb. One of the foundational ideas that gave birth to science and the Enlightenment is that of the skeptical mind. We treat every idea, wherever it comes from, with a certain degree of distrust. This is doubly true for our own ideas. To quote everyone's favourite physicist, Richard Feynman, the first principle is that you must not fool yourself, and you are the easiest person to fool. What this means in software is that we should treat our own ideas and everyone else's with skepticism. and think about the ways that our ideas may be wrong. But we also need to think about that in the context of our code. Code is really just ideas that are crystallized into a form that a computer can execute. So if our ideas can be wrong, our code can certainly be wrong too. If we take this seriously, then we must work in ways that permit mistakes in our code and allow us to recover from them even if we find them much later. I don't mean mistakes only in the somewhat simplistic sense of the code doesn't work. Code can work exactly as intended, but our intentions could still be wrong. There are lots of ways that we can be wrong. Let's start with the fine-grained detail. Obviously, we can make a mistake in our code that means that it doesn't do what we think it does. This is completely normal in coding. We all do this all of the time. We do off-by-one errors, we get conditionals the wrong way round, we forget the syntax of libraries and functions that we use, and so get the parameter order wrong. Good design and some language and tool choices can help with some of these problems, but these kinds of mistakes are best solved with testing. Test-driven development eliminates lots of these kinds of errors completely. TDD is a very evolutionary approach to designing software when done well. The trick is doing it well. Our aim is to create tests that don't fix our design too tightly. We need the ability of our design to live and breathe a little bit and give us the confidence to change it when we learn more. This is an important freedom that enables evolutionary design. One of the reasons that I value test-driven development as highly as I do is because it encourages a particular style of design that enhances this ability. I talk about this in more detail in my book, but test-driven development demands of us that we create testable code. Testable code has all of the hallmarks of high-quality code. That is, code that helps us to manage its complexity. Fundamentally, that means that we can change it safely in one place without worrying too much about those changes creating problems in another. That lays the foundations for our ability to change our minds as we learn new things. So this gives us a second, deeper advantage in maintaining our ability to evolve. So what I'm talking about here is organising our work in a way that defends our ability to change our code. The next idea is that we need to have a target in mind. If we're going to make progress by a series of small changes, some of which are probably wrong, how do we figure out which changes are wrong and which ones are right? I talked about that in more detail over here. But to recap, it's really pretty simple. We make our best guess of where our target should be. A hypothesis, if you like. This guess, too, is probably wrong. But the really nice thing about an evolutionary approach is that we don't have to guess right first time. Now, we iterate, checking after each small step to see if we're closer to or further from our target. If we're smart, we're probably tracking other information on a regular basis too. Stuff that tells us if our target's in the right place. When we learn that it's not a good idea, or when we discover a better target, we can move the goalposts and change our measurements that show us if we're on track to match. Our target is never wholly in our control. Users may hate our early ideas. We may get the scale of our system completely wrong, or the interface to that other component that we rely on may change. If we build our system for millions of users but only 10 people show up, we've wasted effort. If we build it for 10 and millions show up, that won't work either. So if all of this stuff is so fluid, how on earth do we cope? This is what I mean by working to manage the complexity. We work in ways that allow us the freedom to make progress, while at the same time leaving the doors open to new ideas and correcting mistakes. There's a lot of art to this. It depends significantly on the luck, experience and skill to do a good job. But the real skill that I see in the people that I have seen who are really good at it is that they take a very defensive approach to design, mainly using the principles that I describe for managing complexity. Let's look at a simple example. Imagine that we've been tasked with building a system to process orders for books. Let's imagine that this is our goal. A book buyer can go to the store, search for a book called Modern Software Engineering by Dave Farley, put the book in their shopping cart, go to the checkout, pay for the book, and after that they own the book. Where do we start to build a system like this? Sure, I'd start with tests and recommend that you do the same. But today we're talking primarily about design. So as long as you promise to remember that I mean test all the time, I'll skip reminding you about testing for the moment. We could just pile in and build this all as a single simple system. We could start with a list of books in a file perhaps, and build all of the features that I just mentioned, including a UI to access them, into a single process application, accessing the file for the details of the book and updating it when we sell one. If that was all that we did, it would work, but it would be rather limited. As I've described it, this is a single user system, so we can sell one book at a time. Actually, it's worse than that. Unless we'd thought about it and coded for it, it's probably going to break even if we share access to our bookshop to multiple people. So not only can we only sell one book at a time, the only way to control that really is to only allow one person into the shop at a time. There are several things going on here, and we're just starting out, so we don't know the answers for several of these things yet. How many users? How many concurrent users? How many books? How do we update the book lists, etc., etc.? We haven't even said if this is a console, web or mobile application. So assuming that we're going to start, it would be sensible to try and hide some of the stuff that we don't yet understand. Assuming our design is that the file with the books also holds details of prices and stock so that we can sell things, then that is one obvious part of the problem. Inevitably, we're also going to need to allow people to search for books. So we'll have a UI to worry about that too, whatever form that takes. Maybe your head is now going in the direction of, aha, let's build a 3-tier system. And that's probably the next simple step. We could certainly improve things a little bit that way. If we picked a relational database, perhaps we could support multiple concurrent users at the cost of some increased complexity in our code, sure, but also there are some limits to how far this scales. Hundreds of users? Probably okay. Millions? Certainly not. So there's a lot of uncertainty around this choice. While we're starting out and don't have any users at all, it'd be rather foolish of us to do all of the work to build a system for millions of users. Maybe better if we can check out our ideas quickly and easily first. So let's look at our storage problem. We could decide that since we don't know what makes a sensible solution for our future storage needs, we should defer this decision until we've learned more. So, can we write a version of our bookstore that doesn't fix the storage decision? Of course we can. This is software. We can do anything we like, really. Our understanding of the system so far tells us the degree to which the store cares about books. Clearly, each book needs a title and an author so that we can support searching. And it probably needs a price too to support the buying part later on. So let's start there. Instead of designing everything together from the start, let's use some abstraction and create a separate module for supplying us with books, a book repository or a book list perhaps. We could imagine adding an interface to access these books. Let's start simply. All we need to begin with is that our book list module, given a title and an author, can find a book. So that we could imagine now writing code like that. So now we have two modules, a bookstore and a list of books. We could start out with something backed with a file, if that's the simplest place to start, as before. But now the core of our code, the bookstore code, knows nothing at all about the file or how it works. All our store does is ask for books and gets them when it needs them. What's to stop us sometime later replacing the file-based version with a database-backed version? Or what about replacing it with a globally scalable cloud-based data store of some kind in the future? Well, mostly there are two things that get in the way of our ability to do that. The first is the detail of the interface between our two modules. In this case, the details of how we find our book and the representation of the book itself. The second is the degree to which we allow implementation detail about where the books come from to leak out across this boundary. Common complexities in implementation detail are concurrency and stateful context. For the second one of those, I'm thinking of stuff like a database connection. So if we want to maintain our ability to change our minds, then we should probably be a little cautious of those sorts of things. The first part is about good design. As long as the information that represents the book and however we invoke the behaviour to find it is only focused on the store's view of the book rather than how it's stored, that should be fine. So for example, we don't want to pass the database record unfiltered into the bookstore or the bytes that represent the book in our file. We would like to be able to change the storage mechanism without changing the interface. So it's probably helpful here to add something like a ports and adapters style translation to insulate our code from such changes. But really, this is only about focusing on the abstraction of what it is that our store needs from a book list and books, rather than thinking bottom up of how it's stored. The second part may sometimes take a little bit more skill, but principally it seems to me that this is mostly about caring enough to do some work to hide implementation detail. If you start off by thinking, I won't allow any notion of how this works to leak out into the store, it usually pushes you in some much nicer design directions and makes your code more flexible. So okay, this information hiding at the boundaries between modules will cost some more code, but this is a better design, and mostly it will be a trivial amount of code involved in these kinds of facades. They're usually very simple. They concretely encode the essential dependencies that matter in the context of your application. These are not globally generic, they're always a subset of the underlying technology that's doing the storage, so they're always simpler. They provide seams in the code, making our code more easily testable. They mean that we can defer the complex bits of a problem, whatever they may be, until we need to worry about them. There is more to evolutionary design than this, of course. Sometimes we need to think hard about what our future may look like before we go too far. But at that point, all that we're looking for is to understand enough to be able to isolate our concerns so that we can think about them in more detail separately later. This certainly takes some skill, but it doesn't rely on us being omniscient geniuses. And that's quite a good thing, because none of us are. Thank you very much for watching.